Hello, a very good morning to all, and welcome to my class. Today we are going to start a very new topic that it is very important as well, right? So we are going to start today amines, and what was the plan for to complete this chapter now? We try to solve PYQ, and through PYQ only we are going to catch and explain the every topic related to this chapter, right? Because this chapter is very important, and if I'm comparing about all the organic chapter like alcohol, aldehyde, aryl halide, and amines, this one is going to be much easy as compared to this all three chapters, right? So this is important, this is easy, and this is a scoring chapter for you. So just try to listen it very carefully, and if you have any doubt related to this, then please feel free to ask, right? Then let's start with the today topic, that is amines. So we are going to solve PYQ related to this chapter, right? Okay. So, what the first PYQ state beta? That is, identify the product formed from A to E. So you have a several steps in this reaction, and you have to identify the product you will get from A to E. It means you have to identify A, right? And you have to identify E. So these two products you need to understand what these two products are going to be, right? Now, the first one is that is methyl NO2, and it is treated with Br2. Okay, it is treated with the Br2. So what's happened, beta? We know that methyl group is electron donating group, and it favor ortho para directing group, right? Ortho and para directive, where NO2 group is a electron withdrawing group. So what is the possible step here, beta? Whether it will form, yeah, whether this will option A, B, C, D, out of this four, which will most appropriate answer for this step? That is step number A. Yeah. Any idea? Okay. Let's see the solution, right? Then I'll discuss with you that what product you'll form. Basically, here, when this treated with the Br, then we know that as methyl is a electron donating group, then the ortho product will form. And this means this is a Br, right? So this is the formation of A. Now, this when treated with Sn and HCl, right? When this is treated with Sn and HCl, we know that Sn and HCl reduce NO2 group, right? NO2 group into NH2, that is aniline. So reduction takes place, and this NO2 group is converted into NH2. The formation of this takes place. Now, this when treated with NaNO2, we know that this is called BDC. This is called what, beta? BDC, that is benzene diazonium chloride, right? So BDC reaction takes place, and formation of what, beta? That is MEBr N2Cl. Yeah, right. This is BDC, and we know that when the BDC is treated with S3PO2 and H2O, na, then benzene will form. So this BDC part is removed. The N2Cl part is removed. Then what we left with, that is Me and Br. Now, oxidation of KMNO4, we know that whether it's always remember, beta, whether it is toluene like this, okay, or we say it is like cumene, okay, whether we say it is like cumene, whenever it will undergo oxidation, na, KMNO4, whenever it will go oxidation, it always from benzoic acid. Just remember this, it always form benzoic acid, whether they, in benzene there is only one alkyl group or more than one alkyl group, but the product is always what, beta? Benzoic acid. Just remember this fact, right? The product is always benzoic acid. So when this treated with this, the formation of this will take place, that is COOH. So this is our E product, and this is our A product. So this is the answer for this question. So I hope this is not too hard question. It is easy to medium type of question. We can say that, right? So this is the correct solution for this question. Any doubt related to this question, beta? First of all, we know that methyl group is electron donating group. So substitution takes place at ortho and para position. So ortho position here is free. Then substitution takes place at ortho position. Now, when this is treated with SNHCl, we know that NO2 is a reduction of NO2 takes place in presence of SN and HCl. Now, after this, when NH2 is treated with NaNO2HCl, then diazonation takes place and formation of N2Cl. We also know that when the BDC or we say N2Cl is treated with 3PO2 and H2O, then only N2Cl part is removed and the formation of this takes place. And the next and last step is when this is treated with KMNO4 and KOH, then the formation of benzoic acid takes place, right? So these is the final product for this question. So which one is the correct option, beta? That is option number 2. So this is absolutely correct option for this question, right? Okay. So I hope is it clear to everyone? Yeah. Now, next move to the next question. That is the correct order in a aqueous medium of a basic strength in case of methyl substituted amine. Okay, so we know that in aqueous medium, so we have a two type of basic order. One in non-aqueous, and remember this beta, every time questions are coming from this topic. Non-aqueous. Non-aqueous means anything other than water, right? So non-aqueous, I'm saying, okay, in non-aqueous, the order is like this: 3 degree, 2 degree, and 1 degree. Yani, most base is 3 degree, and the minimum will be -1 degree. Now, if I'm talking about aqueous, so what is the order in aqueous beta? That is 2 degree, 1 degree, and 3 degree, right? So this is the order in the aqueous solution: 2 degree, 1 degree, and 3 degree. So in this question, they are asking the correct order in aqueous medium of the basic strength in case of methyl substituted amine. So identify which one is primary, secondary. So out of these, this is secondary amine, this is secondary. So after secondary, there are the primary, tertiary, and then ammonia. Because we know that ammonia is always less basic than compared to aliphatic amine, right? Because in aliphatic amine, one donor group is present, which make this lone pair available more easily, right? So out of ammonia and alkyl amine is more basic. So this is correct. Now, option number 2 is not correct. Option number 3 is also not. 4 is also. So correct option is A, right? So the for this question, the correct answer is 1. That is this order they must be followed, right? Any doubt related to this question, beta? No? Okay. Now, reaction of propanamide with Br2 and KONH. We know that what is this? This is CH3, CH2, and CONH2, right? And reaction with propanamide with Br2 and KOH, Br2 and KOH, right? Then what will take place? Can you please tell me the name of this reaction, beta? What is the name for the particular reaction? Yeah, that is Hofmann's bromide degradation. We already, discussed this question, Hofmann's bromide degradation in our previous class as well. When we are solving our test paper, then we also discussed Hofmann's degradation method, right? So this is the Hofmann's degradation method, and we know that in Hofmann's degradation method, always less number of carbon is formed. For example, in this propanamide we taken now, then the formation of ethane amine will form, right? So out of these four options, we know that when this is treated, then the formation of CH3, CH2, and NH2 takes place. And K2CO3 plus 2KCl plus 2H2, right? This will remove out from this equation. So what is the correct answer for this question, beta? That is option number 4, ethylamine, right? So ethylamine is a major product, or we say product formed when the propanamide is treated with Br2 and KOH, right? So I hope there is no problem in this. Is it clear to everyone? Now, this one is also a very important question, and please try to, remember this question as well, because these type of questions are generally coming because just observe this question. It consists of 2-3 chapters, right? So this type of matching, like name wise reaction, I already told you guys, particular name reaction are very, very important. Always try to learn the reaction, name wise reaction. Always try to learn that type of question, right? Because many times they ask what is the reagent used in this question, yeah, what is the reaction is so called. So match type of question. So these type of questions are generally coming, right? So please try to learn all the name reactions so that you can easily identify the type of reaction. Okay. Now, match list 1 with list 2. So in first step, that is the chlorobenzene is treated with CH3Cl and the formation of toluene takes place, right? And the formation of toluene takes place. So, and the second step, when the Cl is treated with 2Na, then the biphenyl takes place. So we know that this reaction, right? That is when the benzene is treated with Cl in presence of 2Na, right? Again, one chlorobenzene is treated. Then what beta? Then the 2NaCl removed and formation of biphenyl takes place, right? And formation of biphenyl take place. And this reaction is known as Fittig reaction, right? Woods Fittig Woods fitting reaction. So this is known as Woods fitting reaction, right? Clear? Hai? Okay. So we know that B is equivalent to 2, right? B is equivalent to 2. Now, move to the next question. That is when N2Cl, when BDC, when BDC, that is N2Cl, is treated with copper chloride 2, then the formation of chlorobenzene plus N2. And this reaction, we know that this is a Sandmeyer reaction, right? This is Sandmeyer. If only copper plus HCl are present, then it is known as Gutterman reaction, right? So this chapter we are studying halogen, haloaryl, right? So this is, so C stands for Sandmeyer reaction. So C stands for Sandmeyer. This stands for this one. Now, next question is NaI. As we see na NaI, by just looking at NaI, we got to know this is a Finkelstein method, right? Because Finkelstein method is generally used for the preparation of iodine only. And in this method, we also take acetone because only as NaI are soluble only in acetone only, right? So this reaction is known as Finkelstein. So D is equivalent to 3. Now, only one reaction is let me. Oh, there's one, little correction, beta. This is known as Fittig reaction, right? This is known as Fittig reaction, and this is known as Woods fitting reaction. Okay, this is known as Woods fitting reaction because in this CS3Cl plus Cl, 2NaCl removed and the formation of toluene takes place, right? So which one is the correct option, beta, for this question? Which one is correct? That is A is equivalent to 2. It means A 2. Now, B is equivalent to 1. C is equivalent to beta. C is equivalent to 4. So C is equivalent to 4 and D is equivalent to 3. Right? So this is the correct option for this question. So try to look which option is correct, beta. A2, B1, C4. A2, B1, C4, D3. So option number 4. Option number 4 is absolutely correct. Okay. So this is very simple question. If you know the, main name wise reaction, then you can do this question in within 5 to 10 seconds only. Right. So these are the very important and very easy type of question as well. Shall we move to the next question, right? Okay. Now, when benzyl isocyanide can be obtained. So how will you obtain benzyl isocyanide, right? So if you want to obtain the benzyl isocyanide, that is NC, then out of these four option, which option you choose, right? When we treat CH2Br with AgCN, whether it will form benzyl cyanide, that is, what is benzyl cyanide? Benzyl cyanide means nothing better. This means benzyl isocyanide if you want to prepare, na? So just CH3 and NC, you want to prepare this, right? So out of this four, by which option you'll prepare? We know that one reaction, that is carbolamine test. In carbolamine test, uh, when amine is treated with or primary amine is treated with CaCl3 in presence of some strong base like KOH or NaOH, then the formation of isocyanide takes place, right? Then the formation of isocyanide takes place. So in this we prepare, because this is a when primary amine here CH2NH2. So in this we'll prepare, right? And in this will prepare? No, because this is a secondary amine. So it's not possible. Here also not possible. This one will possible or not? That is CH3, CH2Br when this treated with AgCl. We know that whenever CH2Br, CH3Cl is treated with AgCl, then the formation of what takes place, beta? Yeah, NC. Or when this CH3Br is treated with KCN, then formation of cyanide takes place. So which one is the correct answer for this question, beta? Here also we can prepare, here also we can prepare. So out of this through two way, that is A and B. So through A and B, we can prepare isocyanide, right? And rest of that we cannot prepare isocyanide. So these two are, it means which is the correct option, beta? That is A and B. So option number third is absolutely correct. Okay, right. Is it clear? Any doubt? No. Okay. Move to the next question, beta. That is for this question, the question is giving that is a para-nitrotoluene, right? And this name as X, and if you want to convert this into Y. So in the above conversion, compound X is product and Y is the sequence of the region to be used will be, right? So just out of this four option, you have to find out the correct one by which you can prepare this, right? So you have to follow the correct sequence, like which reagent you used for the preparation of this following product, right? So let's see and observe very carefully, beta. For example, if I'm treated with this Fe and H, the formation of what takes place, beta? That is NH2. We already discussed this. Whenever NO2 is treated with, right? Whenever NO2 is treated with Fe in presence of some acid, then the reduction of NO2 group takes place and converted into what? It converted into NH2, right? So this will form. Now, when the NH2 is treated with Br2 aqueous, then we know that whenever the aniline is treated with Br2 aqueous, then the formation of 2,4,6, right? 2,4,6 tribromophenol, 2,4,6. So here, this is 1, 2. So this is 2, number 2, 3, 4. 4 already substituted, 4, 5, and 6. So 2, 4, 6. We say 2 and 6 dibromoaniline will take place. Now, when we treat this with HNO2, na, then what happen, beta? Then this NH2 is converted into N2, right? And then we treat it with S3PO3, then it will convert it into Br and Br only, right? This N2Cl group is removed by the S3PO, right? So this is basically, it is very much similar to the previous question, like when we converting, sequence of reaction in which we find A and E as a product, right? So it is very much similar to this. Just identify the steps, right? Okay. So in this, the fourth option, that is first step, we treated with H plus, then the formation of what takes place, beta? Aniline. When aniline is treated with Br2 aqueous, then the formation of 2 and 6 dibromo aniline takes place, and this was treated with HNO2, then BDC formation takes place, and now with S3PO2 we remove this, so the formation of this will particular takes place. So this is very important, and this is also very good question to make you feel so comfortable that how can questions are related from each other, and by doing such question now you can actually got to know the level of question and which type of question they are going to generally ask. Okay, so I hope is it clear to everyone. Shall we move to the next question, right? Okay, now in the given reaction sequence of the major product C is, you have to identify the correct one. That is when we treat C8H10 with HNO3 and H2SO4, then the formation of A takes place. Now when the A is treated with Br2, then the formation of B takes place. Now when this is treated with alcoholic KOH, formation of C takes place. You have to identify what is C here. So what is with a C8H10? What is C8H10 here? C8 and H10. Try to देखो, एक important चीज ध्यान रखना. Always remember one important thing here ना. Whenever the difference between carbon and hydrogen is very less, whenever the difference between carbon and hydrogen is very less, always think for the aromatic compound. Always go for the cyclic compound, right? Always go for a cyclic compound. When the difference between carbon and hydrogen is much big, or we say, yeah, it is valid, like difference between 6 or 7 takes place, then you'll think about, okay, it may be chain as well, like aliphatic as well. But whenever the difference between the carbon and hydrogen is very less, then always think for a cyclic compound, or we say aromatic compound, right? Now, this will treated with HNO3. So let's see the solution better. This is nothing but what? This is nothing but ethyl benzene. Now, when this treated with HNO2, we know that this is an electron donor group, right? So it will make which product? That is also para, and para is a major product, so NO2 formation takes place. Now, when this NO2 is treated with Br2, then what happened, beta? Then this Br2 is, you know, attacked to this point, and Br, NHBr removed, and formation of Br takes place, right? Now, when this is treated with KOH, then the KBr is removed and the formation of this will, that is, here dehydrogenation takes place and this will form, that is double bond and NO2. So which option is correct, beta? That is B. B is absolutely correct answer for this question, right? So in this question, what we consider like this, we take that is CH2 and CH3 only, right? So this is C8 and H10, right? And when this is treated with HNO3, it will become nitrobenzene and so on, right? So I hope is it clear? It is also a very simple question. Okay. The next question is the conversion of propane 1-ol to N-butylamine, right? The conversion of propane 1-ol to N-butylamine involves sequential addition of reagent. The correct sequential order of reagent is what you want to convert, beta? Propane 1-ol, like CH3, CH2, CH2, and OH. So this is called propane 1-ol. So you want to convert this propane 1-ol into propane 1 into N-butylamine, that is CH3, CH2, 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 and NH2. Here also the chain of the carbon is increased by 1, right? So which reagent you use, beta, basically for the conversion of this into this, right? When we treat when we treat with HCl, let's see, when we treat with this SOCl2, we know that SOCl2 is very good reason for the conversion of alcohol into alkyl halide. Then the formation of what takes place, beta? CH3, CH2, CH2, and Cl. Now when we treat this with the KCN, right? KCN, then CH3, CH2, CH2, and Cn takes place, right? Now, in the next step, when we do the reduction, that is Mendes reaction, that is H2 and nickel, or we say NaHG, sodium amalgam, in the presence of ethanol, then the formation of this will take place, right? So which one is the correct option for this question, beta? Option number A. Yeah, first of all, it will be treated with SOCl2. After this, it will be treated with KCN, and later it will be treated with reducing agent like Mendes reaction. This is also known as Mendes reaction. So by this, we can convert propanol into N-butylamine. Okay, I hope is it clear? Yeah, it's a very simple question. So the correct answer is A. Okay. In this question, the reaction of RCONH2 with bromine and KOH. Again, this is a Hofmann's bromide degradation reaction, right? RCONH2. And this will treated with bromine, that is Br2, and KOH, right? And it will give RNH2. We know that. This is already given in the question as the end product. Which one of the following is the intermediate product formed in this reaction? So you have to identify the intermediate product formed in this reaction. So which one of the following out of these four options, which one will be the intermediate product? Means before product, okay, before product and after reactant, some substances formed between the product and reactant known as intermediate product. So you have to identify the intermediate product in this. Let's see the mechanism behind this. So the given reaction is the Hofmann's bromide degradation method, in which RCONH2 is treated with the NaOH. Now, the strong base comes OH and it will take this H, right? So, in this, that is RCO, NH negative and Br. This Br is removed. Now, from this, we can see that now, whenever this OH will come, then this will suppose this, okay, it will give, it will give this lone pair to this one, right? And the formation of this takes place. And by the proton transfer, we got to know that is the formation of this one will take place, right? Like RNHCO negative, NHCO, NHCOOO negative, right? So out of this four, which option is correct, beta? Right. So out of this four, which option is correct? Yeah. So we can say that this one is absolutely correct, right? So in this, the formation of this will takes place, right? RCONH this. So these are the intermediate product for this question, right? Okay. Now, move to the next question. That is the final product C in the following series of the reaction. So you have to identify the final product. So we know that NO2 is treated with SNFCl, then again formation of what takes place, beta? That is aniline, that is NH2. Now when this NH2 is treated with NaNO2, then BDC, BDC takes place. Now when this BDC is treated with the beta naphthol and NaOH, so C form, and you have to identify which one is C, right? So you have to identify which one is C. When the BDC is treated with this, then what is C here? So beta, this is the structure of beta naphthol. Okay. So what takes place now? Just try to look at this. This is BDC, right? Let me draw first. This is BDC. Now, when I treat with beta naphthol, what is beta naphthol, beta? This one, right? So we know that this having H, this having Cl. So here, removal of HCl takes place. And the formation of what, beta? That is this one, this, and double bond, and azo compound, right? Yeah. So this is the formation takes place. This is known as what? This is known as, we also know this type of reaction is also known as a coupling reaction, right? So in this, the formation of this takes place, that is NN. So which one out of these three, which one is correct option, beta? Out of these three, two, which one is correct? Correct. Yeah, this one, right? So option number A is absolutely correct for this question, right? I hope is it clear to everyone? Right. Okay. So option A or option 4 out of these two? Yes, beta. Which one will correct? Option A or option B? Yes. Option A and option B. Out of these three, out of these two, which will correct? Yeah, that is option A only, right? So this is the correct answer for this question. Now, here two statements were given. So this is statement wise question. I have to identify which statement is wrong and which statement is correct. So statement one. In statement one, what statement one state, beta? It Hofmann's degradation reaction, the migration of only an alkyl group takes place from the carbonyl carbon of the amide to the nitrogen atom, right? In Hofmann's degradation reaction, the migration of only an alkyl group takes place from a carbonyl carbon of the amide to the nitrogen atom. Statement 2 states that the group is migrated in Hofmann's degradation reaction to electron deficient atom in the light of the above statement. Now choose the appropriate answer for this given question, whether first and second statement true or wrong. Now let's observe carefully. When this RCONH2 is treated to Br2NaOH, then the formation of this takes place. We already know this. Now RCONH2 react with OH to form RCONH and this Br2 to form RCONHBr. Now this RCONBr, that is migration of R takes place. That is R and NCO, right? So in this reaction of alkyl as well as aryl group can be migrated to electron deficient nitrogen atom, right? So statement 1 is not correct because statement 1 say that migration of only alkyl group. It is not true. Migration of maybe aryl group also takes place. So statement 1 is incorrect, but statement 2 is absolutely correct, right? So statement 2 is correct. So correct option is D. So correct option for this question is D. Now, identify the major product formed in the following reaction. When the aniline is, okay, something is missing in this question, right? When the aniline is treated with Br2 and H2O. The first step is Br2 and H2O, right? Then the formation of A takes place. Now, this will treated with the NaNO2 and HCl. NaNO2, NaNO2 and HCl. Then B takes place. Now this will treated with S3PO2, S3PO2, S3PO2. Then C takes place. And you have to identify a major product in the following. That is, you have to identify the C, right? So we know that when the aniline is treated with Br2 aqueous, then the formation of what takes place, beta? Then the formation of takes place 2,4,6 trinitrophenol, right? So this is aniline, this is Br, Br, and Br. This is known as 2,4,6 trinitroaniline, tribromoaniline, right? Now, when this is treated with NaNO2 plus HCl, then we know that NH2 group is converted into BDC. So this will become N2Cl, Br, Br, Br. Now, when this is treated with S3PO2, now we know that N2Cl become is totally removed and ring become benzene ring, right? So this will become N2Cl part is completely removed and this will form Br, Br, and Br, right? So this is the correct, this is the correct C product. So out of these three options, which one is correct, beta? Yeah, that is this one. For example, this one, right? It was 2,4,6 tribromobenzene takes place, right? This one. So this is the correct answer for this question, right? So this is also a very simple question, I guess. Now, the next question is a primary aliphatic amine, right? A primary aliphatic amine on reaction with nitrous acid. So let me write first primary aliphatic amine like CH3, CH2, NH2. So this is primary aliphatic amine on reaction with nitrous acid like HNO2, nitrous acid. And after raising the temperature of reaction mixture to the 29, it's given what it's give. Whether it will give alcohol, whether it will give nitrile, diazonium salt, or secondary amine. Yes, beta. So out of this, which will be correct? Yes, this is alcohol, definitely, right? So this is the very simple reaction. That is, whenever the primary aliphatic amine is treated with nitrous acid, and after raising temperature of the reaction mixture to the room temperature, then the formation of alcohol takes place, right? Now move to this question. What the question asks, beta, with respect to the following reaction, consider the given statements, right? Because you have to consider the given statement. That is, this is aniline, and aniline is treated with HNO3 and H2SO4. Then what product you get, right? So in this now, whenever the nitration of aniline takes place, we observe very different observation in this question, because we know that if aniline is an electron donating group, then it's supposed to be give only ortho and para, substitute. But in this, ortho, para, as well as good amount of meta product is also formed, right? Let me see. Let me write the reaction for this. When this aniline is reacted with HNO3, H2SO4, right? When this aniline is treated with HNO3 and H2SO4, then the formation of ortho substituted para substituted, as well as well as meta substituted also form. And you got, to surprise, this will form only 2%. This will form 51%, right? And this will 47%. So this unknown one, that is we are thinking there is no possibility of formation of meta nitroaniline, but in this a good amount like 47% of meta nitroaniline will form. So why is it so better? Because aniline in acidic medium, right? Because this one is aniline. Aniline in acidic medium act as a aniline ion, right? This is NH3 plus. It acts as an aniline ion in acidic medium, and aniline ion has a strong tendency to form meta product, right? That's why this phenomenon takes place, and the good amount of meta product is also formed. Now come back to the question. Question asked: orthonitроaniline and para-nitroaniline are in the predominant products. Whether it is true? No. Para-nitroaniline and meta-nitroaniline are the predominant product. Yeah, this one is correct because one is 51% and another is in 47%. Now, HNO3 act as an acid. Here HNO3 act as an acid. H2SO4 act as an acid. Now you have to identify which statement is correct and which statement is right. So here HNO3 or H2SO4, which one act as an acid beta? H2SO4, right? So this will act as a acid. So statement B and D. So B and D. And what about C beta? HNO3 act as an acid, H2SO4 act as an acid. So we know that B is the correct option, right? So A and D are correct, or we say B and D are correct. So B and D are the correct statement. That is option number C. So for this question, option number C is absolutely correct answer, right? So this is how you can solve this question, right? So this is very important question, and there's one exception behind this. That's why this question are generally coming in our examination. Why good amount of meta product is formed in this reaction? So just tell, because aniline in acidic medium behave like aniline ion, and aniline ion is a meta directing group. So this is the reason behind it, right? I hope is it clear to everyone? No doubt. Okay. Now you have to identify the correct correct reason for this conversion. That is, when the aniline is treated with Br2 aqueous, A form, then NH3 is treated with CS3 anhydride, then the formation of B place. You have to identify which one is A and which one is B. So we know this one is very simple. We did many times this type of questions, right? When the NH2 is treated with the Br2 H2O, right? So then the formation of what takes place, beta? 2, 4, 6. This is NH2, this is Br, this is also Br, this is also Br. So the formation of 2, 4, 6 tribromoaniline. So A is correct. A, we having no doubt. So out of this four option, which having A like this, yeah, only two. So just cross this one and this one. There is no use of this. So only stick into the two option, that is B and C. So this question we are going to do by the option elimination method, right? So there is no use of A and D, just neglect it. Now we remain with B and C. So what the next product? That what happened when the aniline is treated with the CH3CO2? Is it possible that we'll get both same product? That is, here also we get this, here also we get this. No, it won't possible now. So what is the correct option for this question, beta? Yeah, obvious. This is C. That is option number C, right? Because we know A is very much, and A and B we get same set of the product. No, it's not possible. So this one is the, and if you want explanation part, then this is the explanation. When the aniline is treated with anhydride, then the formation of this takes place. Now, when this treated with Br2 in the presence of CH3CONs, then the amide formation takes place. And by the reduction, we get to know that the formation of parabromoaniline. So the two main product is, this is called as A and this is called as B. So these two are the major product for this question, right? I hope you understand. It's very easy questions, right? Because आदत हो गई ऐसे क्वेश्चंस की अब हम लोगों को, है ना? अभी मॉर्निंग से ऐसे ही क्वेश्चन कर रहे हैं हम लोग. Then we got to know, yeah, this type of questions are only coming like this. So it is very easy. Now, next move to the next question. That is what happened when CS3, CS2, Cn is treated with CS3, MgBr and ether. And after this, we treated with S3O. Then after this, we treated with Zn, Hg and HCl. Then formation of what takes place. So we know that beta, this is whenever the CS3, CS2 and Cn is treated with the CS3 MgBr. What happened beta? This is Grignard region. So nucleophilic addition takes place. So in this CH3, CH2, and this is nothing but C triple bond N, right? So in this, what takes place? This want to know, because this is much more electronegative. So here C comes into the support, right? So CH3, Mg and Br. So this CH3 will support here. Now the formation of CH3, CH2, C, and this is CH3, double bond, and Mg and Br, right? Now, when this is treated with H2O, then what takes place, beta? When this is treated with H2O, then this will be CH3, CH2, C, right? This will be C, double bond O, CH3, and MgBrOH plus NH3. So the formation of ketone takes place. Now we know that when the ketone is treated with the zinc amalgam NaCl, this reaction is known as what? Yes, beta. This reaction is known as what? When the ketone is, we already discussed this question in in last class when we were discussing aldehyde and ketone. So whenever the aldehyde or ketone is treated with zinc amalgam, it is known as Clemson's reduction. So in Clemson's reduction, we get only alkane. So out of these four options, which one is correct? That is option number A. Because in option A, we only get the alkane, right? So this is absolutely correct answer for this question, right? So this is all about the Clemson's reduction, right? So it is very, easy question we can say, or we can say this question is, mixture of two chapters. Like in this, we use the concept of aldehyde ketone as well, or we use the concept of, amine as well. So this is very, very important question. These type of questions were. Okay, next question is also a statement based question. Assertion A and reason are given. What assertions tell us better? Experimental reaction of CS3Cl with aniline and anhydride AlCl3 does not give an पैरामिथाइल एनिलीन. कह रहा है ये कि आप ना काम करो, आप ले लो aniline. Just you take aniline and treat this aniline with CH3Cl in presence of AlCl3. So what indirectly, what this reagent is used in which reaction beta? This is used in a Friedel-Crafts alkylation. So Friedel-Crafts alkylation is not possible for aniline because this one acts as a Lewis base, want to donate electron, and this one acts as Lewis acid. It want to gain electron. So these two react with each other और इसको बेचारे को छोड़ देते हैं यहीं पे. ठीक है, इसको तो लेते ही नहीं है. So this reaction won't take place. So this point is must remember to learn that is aniline never undergo Friedel-Crafts alkylation, right? Okay. The reason is the NH2 group of aniline become deactivating because of the salt formation with anhydride NCl3. Hence, yield of methamethyl in the product. So whether it is correct or not, because explanation here is Lewis base and Lewis acid. So let's see the option, right? That is A is true, but R is absolutely false. There is nothing to do with the correct reason, right? Because in this, what the main reason behind this beta? The reason is NH3 group behave as a Lewis acid, where this behave as a Lewis base, and they react with each other, right? So there will be no reaction. So first statement is absolutely correct, but their explanation is not correct. Now, hydrolysis of which compound will give carbolic acid, right? Hydrolysis of which compound will give carbolic acid? Any one of you know what is carbolic acid, beta? What is carbolic acid? And hydrolysis of which compound will give carbolic acid? Cumene, benzene diazonium chloride, benzyl chloride, or ethylene glycol ketone. So out of these four options, which will give carbolic acid, beta? Yes, beta, carbolic acid means this, right? So when the BDC, when we hydrolyze BDC, then the formation of phenol H2 plus HCl takes place. This is known as carbolic acid, right? So just remember this word as well. What is carbolic acid? ठीक है, नहीं तो यहीं पे कंफ्यूज हो जाते हैं कि कार्बोलिक एसिड क्या हो गया हमारे पास. So just try and remember this word, that is phenol is also known as carbolic acid. This is very important thing, right? Phenol is also known as carbolic acid. Carbolic acid, right? So phenol is also known as carbolic acid. Okay. Now, the correct sequential order of the reagent for the given reaction is, you have to identify the correct reason for the conversion of this. We know that in this NO2 and NH2 group is present. So when this NH2 group is first treated with the HNO2, then the formation of BDC takes place, beta. Right. The first step, when this is treated with the HNO2, then the formation of BDC takes place, right? Yeah, this one. That is, this is NO2, and this will become N2Cl, right? BDC. Now, when we treat this BDC with when we treat this BDC with Ki, right? When this treat with Ki, then the formation of what takes place, beta? Iodine negative, and this will anode. So first part, bottom part is done. Now, how will you convert NO2 into OH, right? So you just convert NO2 into OH. So HNO2 is correct, Ki is correct. Now next step is whether we will treat it with HNO2 or we'll treat it with the FeH, right? So let's see, like if you convert this N2Cl ion, this part is very much clear. Now when this treat with FeAs, this will become NH2 again. Now this treat with HNO2, N2Cl, and N2Cl warm, we get phenol. So this is the correct. So we already did this question, right? This type of question when we convert NO2 into aniline by using FeH. So which one is the correct option, beta? FeH, HNO2, right? FeH, and the next is HNO2 and H2O. So B. So B is absolutely correct answer for this question. If you want to convert from this to this, you can do this, right? I hope is it clear to everyone? Right. Okay. So by this, we can convert this. Now, next and the very important type of question is this. You have to match list 1 with list 2. That is benzyl sulfonyl chloride. So what the use of benzyl sulfonyl chloride, beta? Yeah, it is test for primary and it's the Hinsberg reagent and known reaction of isocyanide. So we know that benzyl sulfonyl chloride is Hinsberg reagent. So this is A. The correct option is A. Now Hofmann's bromide degradation. Test for the primary amine. Known reaction for the anti-CGF, yet test for the primary amine. So let's see. Carbolamine reaction means carbolamine are used only for the known reaction of isocyanate. Test for the primary amine, or we say, yeah. So carbolamine reaction is used only for the test of primary amine, right? So this is C. Now we have left with Hofmann's orientation and Hofmann's bromide degradation. So out of these three, known reaction of isocyanide, no. Anti-CGF, yes. So what is the correct one, beta? This is known as Hinsberg reagent. Just remember this formula as well. That is benzene sulfonyl chloride. Now, Hofmann's bromide reaction known as reaction of isocyanide. Just remember this. Hofmann's bromide reaction is known as reaction of isocyanide. When this is treated with this, then formation of this. Because in this now, intermediate RNCO form, right? RCNO form. This is called isocyanide. This is known, that's why they are also known as reaction of isocyanide, right? So Hofmann's bromide reaction is also known as reaction of isocyanide because in this, the intermediate product, already one questions are coming from this topic, right? What is the intermediate formed in the Hofmann's bromide degradation? That is isocyanate. We already discussed this as well. Now, what is carbon-amine reaction? It is used for the test of primary amine also. Hofmann's orientation means anti-Sirjev, formation of less substituted alkene as a major product, right? So that is anti-substituted. That is the formation, just reverse of the Sirjev rule. Because according to the Sirjev rule, the major product are formed by those which having more substituted alkene, right? So here anti-Sirjev means formation of less substituted alkene as a major product. So I hope is it clear, and it's very important. In this question, we learned two new things like what is reaction of isocyanides and intermediate form in this reaction, right? Okay. The next question is identify the correct statement for the given transformation. You want to convert CH3, CH2, CH2, CH3, and tertiary amine convert into this major and minor. So you have to identify which one is the major product and which one is the minor product, right? So just identify the major and the minor product. We know that with when we treat this with ETOH, then the major product will be this, yeah, because this is ethyl alcohol. Okay, or if you treat this with, then major product will be from this, and this will be the minor product. And this is according to what? This is according to the Hofmann's product. These are the Hofmann products, right? So these are the correct answer for this question. Now, aniline or nitration give ortho, meta, and para nitro derivative of aniline. This is very much correct because we already discussed now. Whenever the nitration of aniline takes place, it will give three products, that is ortho, para, and meta. Nitrating mixture is a strong acidic mixture. Whether nitrating makes a strong mixture or not? Yes. So what is the correct? Both A and R is true, and R is the correct explanation, right? Due to formation of aniline ion, we already discussed this question, right? Meta product is also obtained in significant amount, right? So it will also form in the significant amount, right? Now, what happened when this is treated with A and NaOH beta? We are product orange red dye. We know that orange red dye formation means this is a coupling reaction. So what is this coupling reaction? When the BDC is treated with what? That is when the BDC is treated with when the BDC is treated with phenol, right? Whenever this BDC is treated with aniline or phenol, tell me the one. Because in one orange red dye form and another there is a yellow compound formation takes place. So in this is treated with phenol. When this BDC is treated with aniline, then the yellow product is formed. This is also known as a coupling reaction, right? So these two, just try to remember these two beta. When this treated with the beta naphthenol, then the formation of orange formation takes place. And when this is treated with aniline, then the yellow dye formation takes place, right? So I hope it is clear. Now, out of this, which one is Hinsberg region, beta? Very simple. That is first one. This is the Hinsberg region for this question, right? So we cover, all the question related to this chapter, and a very interesting chapter we already covered in this chapter, right? And this question really help you. So just utilize this time and just solve such question, and also solve some more question related to this topic only. If you know this topic now, then you can easily attempt one to two question which are going to ask your examination, right? So please learn this and try to utilize this, right? And by solving this question itself, you're getting to know how which type of question they are generally asked and how to solve such question, right? So let's end the session here, and in the next class we are going to start some new chapter as well, right? So thank you for today, and all the best, and just read it well and just study well, right?